screen with you. One moment. Do you see my screen?
No, sir, not yet, sir.
Just hold on. Just 1 minute. One moment. Do you see it now?
Yes.
Dr. Annapurna, can you all see it now?
Yes, sir.
Yeah,
It's
thank you
perfect,
so
sir.
much. Okay, right. So let's discuss with a little bit of history where all this started. Because we stay in a part of the world where the developments were slower initially. I remember when I started, we used to do concrete production manually at the site, where a mixer would come and will produce mostly batching by volumetric batching. Things did not change for a long time till mid-90s, when things start happening rapidly. And quite a few things happened from 95 onwards, and many of the youngsters are surprised to know that the first batching plant in Hyderabad came in 1988, 89, but it stabilized only in 2000. So that was a time when we all started. So we will briefly go through the rapid developments which we have seen in past 25 years. Now, it all began with growth in the cement industry, because prior to that, cement was a controlled product. Only after liberalization of economy in 1990, 91, 92, new cement plants came up in a big way. And these quality of cement produced by the plant increased considerably and give a lot of option to the end user. And then grade 33, 43 were being produced. Then at that time, 153 also started. Along with that, in the late 90s, I would say, the use of cement replacements like flash and GGB has gained. I remember very well in the late 90s, 96 or 97, I don't remember exactly, APSEB, Andhra Pradesh State Electricity Board, which controls the thermal power plants, had a big seminar, and they were quite concerned about the huge mountains of fly ash that was stacked outside their plants, because they use coal, and coal generates a lot of fly ash. And they were really pleading with the developers and the concrete users to come and lift the fly ash without any cost. And in fact, they were willing to help them in getting rid of their fly ash. And then the response was lukewarm initially. And then similarly, GBS basically start from Vizag and other steel plants. They had huge deposits of fly ash, both of these being a byproduct from the plants. So that also came and then started getting acceptability. Then, as I said, 1998 to 2000, there was a trickle of RMC plant, but 2000 onwards, there was spurt in ready mix plants. Initially it was slow only because they gained acceptability very slowly. The end users were not having any trust in the RMC manufacturers. They were not sure whether enough cement will be mixed or not, because they were not seeing how much cement is being put. And then they were told that the fly ash should be mixed in this. They got even scared, because in those days, the mixing of ash in cement, that adulteration was very, very common. And then only the reputed end users started using this, the concrete from RMC plants. Then, fortunately, along with that, the transit mixers also came, because RMC plant without transit mixer has no meaning, because you have to carry them to the construction site for the use. And then the logistics became simpler. Initially, the traffic was low, the movement and was for transit mixers were easy, and they were moving 24 hours. Now we have a lot of restrictions in city now. And then along with that, the concrete pumps also came, and that makes placement easier at the site. Though there was initially some difficulties, because the RMC vendors were not able to supply pumps everywhere, so they would come and dump at the site, and then that has to be lifted manually, either by head load or by the material hoist at the site. So this was the initial time. And along with that, the super plasticizers made it possible to reduce the water cementitious content without affecting, I'm sorry, the out is missing, without affecting the workability. Because what this water, what they did is they reduced the water, but still maintained the workability of concrete. And then retarding agents were added, because from mixing at the plant to the placement at the site would take more than 2-3 hours in those days. Subsequently, it went beyond 4.5 hours too, because of traffic congestion, and then the sites were not ready to receive them. So this made the production of placement of cement concrete possible. And then this revolutionized the entire concrete industry. And then coupled with that, in last 8-10 years, we started the self-compacting concrete being used extensively in Hyderabad, and then in high performance concrete, though it has limited usage and ultra high performance, it's still not reached Hyderabad as such. Maybe for very small purposes, it might be used somewhere. So these, however, the self-compacting concrete and higher grades, I'm talking of M40, 50, 60, made it possible to design taller buildings and long span structures. So earlier, the longer not only because of high strength the utilization of strength of both the materials. And all this happened when the construction boom started. Construction boom started in early. Fortunately, the country was ready with all these logistics and the high strength concrete being made available. And then this boom resulted in high demand for high strength and high performance concrete. And then this huge demand growth brought more players into the field. Now, these sudden change from primitive way to this higher grade concrete and then larger structure, long span buildings, all these pose many challenges before us. And then we will discuss as we go along how we face those challenges, and then the opportunities came in the way, what innovations were made to face these challenges and also make use of these opportunities. We'll take one by one here. So basically, I'll even give a brief note of few points initially, which will sum up later too. Now, we would be discussing a couple of things, which is how to reduce the consumption of materials on account of these innovations, number one. And number two, how to check the carbon footprint. Concrete and cement are notorious material and also steel when it comes to environment. So the impact, and then suddenly we started use huge quantities. It has impacted adversely on the material. So we will even discuss that. And I would probably take 2 breaks, Professor Annapurna, in between, so that we can have a little bit of interaction. As I told you initially, I would like to make this a very interactive session wherein we exchange our ideas and thoughts and develop on that. And then we discuss the next slide is the first challenge, the rising demand and depleting resources. We have to mine most of the construction material which are used in cement or otherwise in the field of construction. So this spurt in construction activity leading to huge demand on essential inputs like cement, and it started impacting limestone and coal. Limestone as raw material and coal being the required for in the production of cement. Then the aggregate, coarse and fines. Now, coarse and fines has another unique problem, because what happened, the mining of sand, I would use the word mining, from the open sources was so heavy that the surrounding rivers and sand pits where sand was borrowed for the development in the urban areas got exhausted too soon, creating havoc on the environment. And ultimately, government banned mining of sand. I remember in our city, Hyderabad, we would get sand from somewhere hardly 30-40 kilometers from your place, like Aler and all. And then some time back, before the sand was mining of sand was banned, sand was brought from, say, about 200 kilometers, 150 kilometers, 200 kilometers. So such was the pressure. Now that the sand mining was banned, so in about 15 years back, we started looking towards crushed sand. We can start converting granite, stone, crushing them into what we call engineered sand, well-graded engineered sand. Definitely, it was from certain technically, it's a better product than the rounded sand, so the sand which you get from rivers. So this is putting more pressure on the coarse aggregate raw material. That's the granite stone which we use here and elsewhere too. So now with this, because of, as I said, cement replacement were also brought into picture, the GGBS as well as fly ash. So there's a resulted in a huge reduction in cement consumption. I'll go up a little back. When we were doing manual concreting, that means the batching at the site, volumetric batching at the site, the 124 was considered as M15. We used to call that M50 then, and 1.5, 3 was considered an M20. And M15 would consume 6 bags. That's about 300 meter cube per 300 kgs per meter cube. And M20 would consume about 7.5 bags, 375 kgs. Huge consumption of cement was happening. But with the advent of admixtures and RMC plants, the pressure on cement reduced considerably. Then high cost of power is also hurting, a big challenge, hurting a lot. And then the mineral deposits, we have to remember that our fossil fuels cannot last longer. Because these are natural deposits. We keep on mining and there is no recharging is happening. So that is one major challenge which we are facing. And then this is a new challenge which we are facing, this non-availability of manpower, both skilled and unskilled. In fact, the manpower requirement has reduced considerably during past 15 years because of mechanization, and then a lot of machinery is being used. Earlier used to do concreting, you would get a batch of 100 laborers to do that concrete, 80 to 100 laborers. Now you do practically with 7, 8, 10 people now. So that way, even though the requirement is reduced, the pressure is still there. And then again, this led to sustainability issues because of the high strength concrete which you're using, and then the other materials which we were using. And then it's environment. Right? These are challenges which we would be discussing as we go along. Yeah. So as these challenges continued, so we aim at reduced consumption of materials per square unit of construction. It's very important. This is very important particularly for designers. You can build X amount of square meter area in 1 unit of material, or you can do 1.2 times, 1.3 times, or even half times that. So it's very important that the design should be such that the total material consumption should be as low as possible. We should not liberally use the material because the same material can be used for a more area for construction. So that's one we should aim at. And then
Excuse me, sir.
optimize design. Hello?
Sir, sorry to interrupt, sir. Actually, the slides are not changing, sir. Just to inform.
Just hold on. Okay, I'm seeing them changing here. Just hold on. You can see me?
Yes, sir. Yes, sir. But the slides are not changing, sir.
Okay, just hold on. Do you see now?
Yes, sir. Yes, sir.
You see it now?
Yes, sir. Yes, sir.
Yeah. Yeah, we were discussing this. Aim at reduced consumption of material per unit area of construction. For that, the designs have to be optimized by using state-of-art software, and then good judgments and sustainable materials. Then usage of higher grade of concretes, this would result in lesser concrete, because as I said, M15 we have moved to M30 now minimum, M25, M30, and I'm pretty sure in next very soon we'll see that even 25 and M30 also will be obsolete. Then the recycling of metal, that's still not happening in India. No? We should, because we are seeing redeployment, redevelopment happening. Old buildings are being brought down. So I'm saying concrete buildings, and old roads are being removed. So whenever we demolish any concrete, we tend to throw it away as debris. I think it's time that the government come up with a clear policy and enforce it, so that the concrete is recycled, so that we can get coarse and fine aggregates, with this debris is sent to those plants, and then they regenerate these from that. Then we need to adopt good construction practices and focus on proper detailing. So lower consumption of material will also result in lighter structures. This is very important. Now, many a times I notice the structures are so heavy, lot of cost is spent on supporting the dead weight of structure itself. So this is one thing. we need to tell our younger generation. In fact, I would love to inculcate this in the minds of budding engineers or who are still in the college, to aim at making structure as light as possible. This will not only use the lesser material, but would also make huge cost saving, because creating strength to dead loads has absolutely no meaning. It's wrong, basically. So we are wasting national resources. So building consuming letter material shall be considered for green buildings and certification. I always wonder, when we look at the green building certification, their focus is only on the operating cost on account of air conditioning or lighting and those areas. Though they give some weightage for the excavation of good soil and replacing it in the surrounding and using that, or using older building materials, flooring and all. But I have not come across having any negative points given to those buildings which consume huge material for the same area, square footage or square meters area. So it would be a good thing if ultimately some kind I know it's difficult because the material consumption in different buildings cannot be same depending on spans and height and all. But still, no, we should be able to work out some methodology by which this also becomes a part of green buildings consideration. Why this is important from another standpoint is the developers and builders are very keen. Even the government also, whenever they are publishing tenders, they are for competition designs, they are insisting that the building should meet these green building norms. So if this is added to green building, where the consumption of material is also hooked up to that, I think that will be something which is very helpful. Now, to note how the steel is becoming more and more popular material, this chart would show you. Now, in 1900 till recently, number of steel buildings were very high. Tall. You talk of tall buildings only 100. This is the 100 tallest buildings per decade. Now we are slowly noticing that concrete is becoming more and more popular as a material in tall buildings too. You can see the red one is the concrete, and then the green one is composite. So composite and concrete, composite construction and concrete are becoming more and more popular material. Because this again, because of this only, because higher grade of concrete is coming. In fact, this is soon concrete will compete with steel when it comes to its compressive strength. Then there is no point is using expensive reinforcing steel or structural steel. So this is another indication towards the acceptability of concrete as a favorite material. Now let's go to high strength concrete. You see this slide now?
No, sir. Slide has not changed, sir.
Again, some issue with the system.
shortly join the
Participants, sir will join shortly. Kindly wait.
Is it okay now?
Yes, sir. We are able to see the screen. Sir, can you
Yeah.
move backward or forward? If we will tell whether this slide is changing or not, sir.
Okay. Is it changing now?
No, sir. It is at high strength concrete only.
It's not changing again. Is it changing now?
Yes, sir. Now it's changing, sir.
Okay. Okay. So challenge is production of, we'll discuss the challenge of production of high grade concrete. So to do that, we started deploying new generation admixtures, such as high range water reducers, viscosity enhancers or modifiers, because water cement ratio, water cementitious ratio, we know is the biggest factor in attaining higher strength. And then viscosity enhances to control the workability of concrete, then water repellents, water proofing agents, and corrosion inhibitors. These we started using that, and then which resulted in production of higher strength concrete. And then the idea was we were able to do that even with reduced cementitious materials. Is changing now?
Yes, sir. Yes, sir.
Hello. Yeah, yeah. Now, then let's discuss the quality assurance issues, which we are facing on a daily basis even now. This again, I'm telling you from the experience of not only me but most of the practicing in the field now. Now, high strength concrete is only produced by RMC plants. We know that. However, there is no entry barrier on setting up RMC plants. Today, anybody can set up an RMC plant. Everybody cannot start a diagnostic center. Everybody cannot start a medical shop. You need to be a pharmacist, or you need to have a degree to pharmacy to start a medical shop, or a degree to start a diagnostic center. But RMC plant is anybody can go and start RMC plant. Somebody is just supplying sand. You hear that he started manufacturing concrete without any technical competence or capabilities. There are no controls as such. So as that anybody can set up an RMC plant, but however, the RMC MA, that is Ready Mix Concrete Manufacturers Association, is the only body which monitors on the performance of the RMC plants by its members. They are fairly strict. That's why very few RMC vendors are their members. Mostly the larger ones. The smaller ones still don't do that. So what is the cause of concern here is cement RMC is not used only in large projects. RMC is used even in smaller buildings too. Big or small, every building is important. Every structure is important. Everywhere the concrete is used is important. But the smaller vendors who are not under the watchful eye of any regulator are producing without anybody knowing what they are doing. So hence there are no checks on that. So end user awareness about RMC is also very low. The end user thinks that as he goes and buys any product from the market, he thinks that concrete is the same thing. So that in most cases, the price is the criteria. He will buy RMC from somebody who gives him very cheap, be it any grade of concrete, 25, 35, 30, 35, 40, whatever it is. And then even though there are designers who would specify, but you can't be sure about the end user. He would look at the credibility of the vendor, and because they are attracted by lower price offered by some of the vendors, they go and buy that. And nobody would do a business by losing money. So they end up definitely cutting cement or whatever admixtures which they were supposed to mix as per the design mix, they will not do that. That is one big challenge for which there is still no solution before us. And then again, because the delay in transit results in surface cracks due to shrinkage. Now, many places we notice that concrete is placed at beyond 4.5 hours after being charged into the transit mixer at the RMC plant. Now, this concrete starts setting very soon, and then if the curing is not initiated immediately, then you will see surface cracks on account of shrinkage, which have to be attended immediately. If they are not attended, then they would remain and then give a very gory picture of the whole concrete surface. The next comes the durability challenge before us. Now that has been basically solved by the fly ash and GGPS, which resulted in reduction of cement. So these are from, as I said, thermal power plants and steel industry, and these constitute excellent cement replacements and together form a good cementitious material. Now the code allows up to 35% of cement can be replaced by GGPS and fly ash, which is the practice now, between 30 and 35%. That is being mixed everywhere, even for higher grades of concrete. So if you notice that even though the cement percentage has gone down, cement consumption has gone down, the grade is going higher and higher. Then they also help reduce the heat of hydration, particularly in the initial periods, and thus improve durability properties of concrete substantially. And then, as I was mentioning you about the delayed placement of concrete, 4.5 hours are extremely critical from the time of mixing. So if that crosses, the concrete heat will be at the peak, which can harm the concrete. And then now again, as I said, the GGPS and fly ash were considered hazardous materials in 1990s, because fly ash, you would say, the fly whenever there's a strong wind blowing everywhere, and then caused a nuisance to the surroundings and was hurting the environment. So it is turned as a boom to both construction industry as well as the plants which were producing them. Apart from that, microcyclic silica or silica fumes are also added for higher grades of concrete beyond M40. For 50, 60, essentially they use it. Currently in India, we are mostly using 40s to 60, and probably very tall buildings we're using M60 grade. You want me to take a break here, Dr. Annapurna? If any questions are there or discussions?
No, sir. Can you please carry on?
Okay. Now, as I said, the temperature control in the initial stages, that is 35 to 55 hours after placing, is important. The low heat design and insulation to reduce the differential temperatures in mass concrete. This problem is very acute in mass concrete because the core temperatures will be very high. Either we have to have ways and to measure the temperature at the core and also at the perimeter. Otherwise, we need to make sure that that enough care is taken, and then the concrete is insulated from that. Now, this graph shows that the variation of temperature at the surface and in the core, it could be as high as 22, 35 degrees centigrade. And then again, water penetration, water absorption is another challenge. And then rapid chloride and penetration tests are carried out to make sure that this is resolved. And the denser the concrete, well compacted it is, the better it is. Then we know that the income, and this is another challenge. The ingredients don't come from same reliable source which was used while the mix was designed. So if one quarry is over, they get from other quarry, or the vendor has a tendency to buy from cheaper sources. So there is a chance that the fines and coarse aggregates properties might vary when the source is changed. And then that might have an impact on the mix design. But once design is arrived at a project site, normally they don't change, even if the raw materials are changed. So that is another change. For that, the best thing to do is increase the sampling, so that we know that the desired concrete is being received at the site. Then maintaining consistency over longer duration. This is only in case of delays. That's another challenge. For that, important of pumpability and compactions is is of prime importance. Then usage of retarders also is very helpful there. And then the other problem which we face is at the sites are generally segregation and improper compaction. I said these problems compound when higher grade concretes are there, because there's not much of margin left for safety. So it's important that the quality of concrete is maintained. So this, the self-compacting concrete, which is rampant now, it's available practically everywhere. Because depending on the human beings at the site, labor the site to do vibration or compaction is very difficult. You will not get uniform compaction, and then over vibrating was very common. So self-compacting concrete has solved this issue to a very large extent. In fact, most of the important locations, only self-compacting concrete is used, and that has excellent, you get excellent compaction without much of effort. And then now again, now we notice in the past few years, of the structural elements are getting thinner and thinner, even in tall buildings. The architects are keen to use columns and beams as no more than 200 mm wide. The code gives a much higher cover, and with the 200 mm wide elements, both column and beam, it's not possible to design the buildings with that. But the architects are very keen. So that's why we are moving towards not only SCC, but also the columns are being replaced by walls, where the code requirements are much lower for the cover. Now this throws a lot of opportunities to us. The availability of higher grades of concrete made it possible to build tall buildings. The tall buildings were not feasible when we were in those M15, M20 days of concrete. Even with M25, tall buildings were not feasible. The higher strength concrete and then the higher grades are made it possible. Then multi-story thin shear wall residential building. This U.C.E has become very common in India. Most of the projects are aiming at that. Now, there are various reasons for doing it. One is the red brick, which was very common in earlier days, is not as available anymore, because red brick manufacturers have made most of the agricultural tracts of land barren. They have taken out the topsoil, used a brick, and then that land had become useless after that. So the agriculture stopped allowing them to use that. And moreover, the taller buildings use lighter material. So and then you know that the red brick density is very high, about 19.5 kilonewton per meter cube. So people move towards lighter walls, and then that's where AAC come into play. And then even with AAC block, you need laborers, masons to come and build the wall and do the plastering. which is very difficult. And then the skilled labor are no more available because the mason's son is not becoming a mason. Carpenter's son is not becoming carpenters. So you are practically working with semi-skilled laborers. So then this thin shear wall residential building, what they use the trade name, the Maiwan formwork, which they call aluminum formwork, has use in a much larger at a larger scale now. So that the building of walls are panel walls are gone, filler walls, and then the plastering is also gone. So you have only, even if a wall building which is 25 floor high or more, you have wall thickness as low as 160 only. So that you cannot do without SCC, the self-compacting concrete. Then off-site construction came into play. Then precast, pre-tension building elements. These are done only in the factories, at the works. And then you need a higher grade of concrete. They use M40 and above. And then these are not only precast, pre-tension. It's not possible to do this without using high-grade concrete. So this is also an excellent opportunity. And then you see in Hyderabad for, again, last 15 years, post-tension floors have become very common. More and more end users, developers want, or even IT building want flat slab buildings, flat plates they want. They don't want beams because that is coming in the way of service zones. That's air conditioning and then electrical and air conditioning. So for that, long spans, they want columns far apart, 12 meters apart in both directions. And without post-tension, it's not possible. And post-tension required minimum M35 grade concrete. So that would not have been possible had high-strength concrete not been there. And long span structures too, whether we use post-tension or not, but the high strength of concrete is a must there. And then even for concrete composite construction, same story. So these structures help in economizing the structural cost when reinforcing the steel prices shoot up. Now, one very interesting thing I would like to share with you, the cement and steel cost and not even the aggregated manpower fluctuate a lot. Someday more steel in a building give you an economical solution. At other times, less steel and more concrete gives you a better solution. No, we were doing an exercise last week only. Now the steel has become so exorbitantly expensive. Concrete did not go up as much. So the less the steel, little increase in concrete will give you a better solution. So the tendency is to use as low quantity of steel as possible, but again have a tight control over on the concrete, because you should not end up increasing the dead loads. Then IT beam led to demand of office spaces with large spaces. Now this increased employment resulted in demand for housing. Overall economical development required massive investments in infrastructure. So most of the roads in city also are noticing are cement roads, no more asphalt or bitumen roads now. So that's why the demand of concrete is going up by the day. And then this is an increased demand of technical manpower in the field of production and uses of concrete. This is good news for us, because our graduates and diploma holders who come out of college have huge potential now to get a job and better placements. But the only thing which I would like to share here is that we should also look at giving them some kind of training at the institution level itself before they come out of college. I think we don't have many concrete experts available now. The boys who come out of colleges are good in all aspects, but when you need somebody specifically to handle the quality assurance of concrete site, they are not available. So I think that we need to really look at what we can do in that direction. Then we are noticing this. Now IT is being integrated in the construction process in a big way. The innovation implementation, as there's a huge time lag in India even now between innovation and implementation in the field, though this is reducing. And then the close coordination between research academia and industry is required. Sadly, that's not so. I would love if that can be discussed, even though for a few minutes in our group today. How do we bridge this gap? How do we make sure, like in medical college, I always give this example. The medicos spend good amount of time in the hospital before they get their degree. But we don't see that happening in civil engineering. I think it's high time we think about that. Therefore, field exposure while in college is extremely important. And then they would really see what they are studying. They will see the relevance of it, and they'll get back to college and discuss with their professors. Then, this we discussed, admixtures, new construction techniques discussed, and offsite constructions also we discussed. Now, BIMS is another area where there's huge job potential for our youngsters, and I'm sure sooner at even graduate level, this should be included as part of the curriculum or elective. And then project management techniques. Now, there is one very strange thing I noticed. Every civil engineer graduate want to be a structural engineer. And then I tell them the project manager makes at least 3-4 times more than a structural engineer. They get more salary and perks. And he has better chances. And for each structural engineer, probably you will have 100 engineers working in the field who draw more than them. So exposure to project management techniques it would be quite helpful to them. So the common myths are, we are all aware of the wrong notion that more cement better the concrete. In fact, less cement better the concrete. Use water to improve workability. We are not doing that now. We are using admixtures, and then this mindset requires a change. Now, this is the forecast. This projected that after 2050, the concrete consumption will go down, newer materials would come, though the population will increase. So I think we still have a lot of time. So we need not worry right now at this point in time. And then now, finally, I come towards the environment aspect of that. Now, a lot of energy is required to produce cement. And energy is one big load on the environment. So cement and energy, lesser the cement, we save on energy as well as we save the environment. I was looking at one of the article recently. They said about 15 billion cubic meters concrete is produced every year, all over the world. Now, most of the cement manufacturers have come together and they have decided that they would reduce the carbon footprint by at least 25% by the year 2030, and you can see that between now and 2030 that it believes will prevent almost 5 billion tons of carbon from entering the atmosphere. So everybody is looking at us that we reduce the cement content and the environment is saved. This is what the Global Cement and Concrete Association members account for, 80%. And then this is what they have vowed, that they will reduce the carbon footprint. Yeah, 40 global cement concrete manufacturers have pledged a new 25% reduction in CO2 emissions by 2030. So let's all help them by reducing the cement consumption. And they want to make it net zero by the year 2050. So I wish they do it, because they say the concrete is the second most used man-made, is the most man-made material used. So that is playing havoc with the environment. So now in India, about 328 million metric tons of cement is used. So this would go up. So we have to look at how we reduce it. Now this is the projections for the cement consumption in next 5 years, the 4 years, 19 to 2022. So now again, finally to close, Now, the focus today is on doing effective product management, how to handle the material very efficiently, and then work on BIMs, artificial intelligence, ultra high performance cements, self-healing concrete, graphic concrete. I'm not going into all that because I think already have taken enough time. And then they want to monitor the concrete and other activities using drones. And then offsite construction is likely to come in a big way to face to save the issues which we encounter. I think I have more or less finished. Dr. Napurna, if there are any questions or any discussion, I'll be too pleased to. Dr. Annapurna, do you hear me?
Unmuting the participants, sir. We will ask, sir, if any participant is having a doubt.
Yeah, any participants have, yeah, if they want to discuss something or enrich my knowledge by because you are excellent in theory. We are people from the field, out of touch with the theory for a long time. I'm sure Professor Napurna, I'll get a lot of tips from the group.
Participants, you can unmute now and you can ask, sir, if any doubt you are having. All the participants. Unmute yourself.
I think they have no questions apparently.
No, sir. Actually, we are looking at mute.
In the chat, let me see
Yes,
the
yes.
questions.
No doubts. Okay. You can write any question if you have. You can write in the chat box also. Nice session. Okay.
Only compliments.
Session is very actually
Most of
you are
them.
so experienced and you explain very well, sir. We are really very fortunate to listen to you, sir. Thank you so much, sir, for taking time. You are busy, I know. You're having meetings, and in between, I requested you to change the schedule. Immediately, you accepted. Thank you so much, sir.
No, I would love to be with the teachers, I told you. But I have only one complaint. You are all not teaching me anything. I thought at least somebody would say that, no, why don't you do it like this, like that? No, but thank you so much. Let me thank all participants. It was wonderful being with you all.
Thank you so much, sir. Thank you, sir.
Thank you so much.
Thank you.
So I log off with this, Doctor.
Yes, sir. Yes, sir. Thank you, sir.
Right. Thanks.
Please share details of your consultancy. Somebody said, sir.
I don't know what these details. I'll do that. I'll send it to you, Doctor.
Okay.
Okay.
Okay,
Thank you
sir.
so much. Bye.
Thank you so much, sir. Thank you, sir.
Pleasure. My pleasure.
Participants, there is announcement to the participants. You are all very much worried about attendance. I know that, but please understand our problem also. We said n number of times. Please be strict to the timing. As we plan to share this Google form to the Zoom platform, immediately somebody is informing in the group that you go and fill the form. Should not be like this, please. Okay, we are all learned colleagues. I said we are all teaching fraternity here. Our students are also sitting here. They are laughing. They are smiling at us. Okay, please don't do this. Okay, I know that you people are very busy. I accept it. But to get the attendance, we should, come on time. And this FDP 129 number, now he is trying to join. Is this the time to join? Please think once. It is already 3:30. Yesterday also I have seen the last session. half an hour before participants are trying to join. It should not be like that. Please cooperate. Okay. Next time I said already that we are going to post the Google form. Along with the Google form, randomly we'll check the attendance also. Because it is not correct. We are posting the Google form immediately. You are transferring the information to other to join and submit the Google form. We are not here only for filling the Google form. Please think that and act accordingly. So tomorrow again we'll meet at 9:45 a.m. for the next session. That is session 10. Hardly we have 4 sessions remaining. Sessions. Okay, it is 9th session, so 10, 11, 12, 13, 14, 5 sessions we have. I accept that you have connection issues also. I accept it, but please see that you should be regular to these sessions. Okay, so tomorrow at 9:45 we'll post the link in the WhatsApp group. Please join. At 10 o'clock we have session. Okay, so please do that. And in this Zoom only we will post the Google form. And regarding the notes, lecture notes, somebody is asking. I already posted all the lecture notes on ATAL portal. I came to know that we are not supposed to post in the WhatsApp groups. Okay, so we will post in ATAL portal. Already you are having your registered ATAL. Through that you can join and you can just get your notes. Okay, I posted all the notes. You can find from your FDP, that is ATAL portal. Okay, thank you so much. Thanks. Good day.